Welcome back. We're up for the next video in INST 314, Statistics for Information Science, continuing the Statistical Foundations module, and this particular topic is focusing on the relationships of the different variables that we have and the data analysis workflow. This video really starts to stitch together how we're going to move through this data analysis process and talk about the causal relationships that we're going to need to know about as we look at the numbers in the data. So let's jump right in. So I was just mentioning in the opening that this entire video is going to be talking about the data analysis workflow and the relationships. And we're going to be framing this primarily in the context of quantitative research, which is the core of statistics. So let's go ahead and jump right in. Quantitative research, or as I like to call it, loving stats. The reason we do this is it's a type of research method. There's also qualitative, mixed methods, and other tools in our research toolkit. But the focus of quantitative research is to what we call empirically testing an idea to see if this is right. By empirically, we mean we're not going to rely on just theory and logic to come to a conclusion, but we're going to look at things that we can actually observe and measure and quantify. So the things that we're quantifying and that we're trying to drill out here are the different ideas that we have. The things that we come across in our daily lives and just say, oh, I have an idea, or I think this, or he or she thinks that. So these are things that are beliefs, speculations, predictions about how the world works. Some examples I have here for you include younger people have more interest in recycling. People from the suburbs oppose permits to use Chicago beaches. Yes, shout out Chicago, that's where I'm from. Poor people are more likely to use public transit. We build these ideas into theories, and theories are the predicted causal relationships among the different variables that we have. So in order to construct your theory, you have to have a firm understanding of the unit of analysis, the variables, and the relationships. So again, just to kind of recap, the variables organize data. And so the things that we're measuring, what is it that could vary that we are measuring? So when we're talking about the recycling, how much does somebody recycle? Some, quite a bit, not at all. And if we're talking about someone's opinion about using a beach permit, the thing that we're measuring is an opinion about that specific topic. You could be for it, against it, maybe you don't care at all. And if we're talking about something that's maybe more numerically driven, we could talk about the number of rainy days in the year. And in that case, we would just be getting a count. How many rainy days did we have? When we're talking about the unit of analysis, to recap on this one, which we covered in the previous lecture, it's what the group is that we're doing the prediction about. So in the examples I gave you, people were the unit of analysis for all of these. We could make it a little more nitty-gritty if we're trying to define them, but if we want to keep the variation, we had to keep it at the higher level of people. You couldn't necessarily say younger people as unit of analysis, because then we might have to consider younger people compared to whom? Older people? Or if you're looking at younger people, then do you have groups within those that you're talking about younger people or not? So in this case, the unit of analysis is just people. So when we break it then into the relationships portion, there's different ways that we can structure this, the way we talk about it, the way we write it and draw it. So the relationships are really what is causing what. Verbal relationships refer to one variable causing another one. So we could say that age causes an interest in recycling. That's when you're saying if you're younger or older, is that affecting how much you choose to recycle or not? Causal diagrams are functionally the same as the way we do it verbally, but instead of using words like causes or associated or corresponds to, we remove those action words and replace it with an arrow, a diagrammatic arrow that has it's a directional arrow with a point on one end going from that which is doing the causing towards that which is being affected. So again, I just need to kind of reiterate and reaffirm, theories are always expressed in terms of variables, right? So we're backing up that age could vary, younger or older, and how much you have an interest in recycling could vary, some, not at all, a little, quite a bit. And so those are the things that we are varying, and we're saying that one variable influences the other is the theory itself. So then we can get down in terms of talking about these things abstractly, right? We can talk about how the variable x causes the variable y. And another way that we can talk about x is in terms of independent variable causes the dependent variable. Keywords there being independent and dependent where independent is the one that's in control or individually, causing a dependency for the dependent variable. So when we're then talking about this, we have to think about the causal ordering. Does X point to Y? Can Y point back to X? Can they point at each other? There are instances in the real world where we find things that are called mutually related, where they feed off of each other in a sort of symbiotic sort of fashion. I just want to kind of bring up to you that as you go through the readings, whether it's in your textbook, the videos, I will purposefully interchange certain terms to get you exposure to them, because certain communities out there in the work, and on the internet for sure, are going to use terms that are synonymous to each other, and I just want you to be familiar with them. So X and Y are the two that I just used, along with independent and dependent. But the X's and independence could also be called explanatory or predictor, and Y's and dependence could also be called response or outcome. And I've put them horizontally across from each other because you usually see explanatory and response together, predictor and outcome together, and so on. And just to kind of, again, reiterate, depending on what communities you're working in may influence which terminologies that you see. So let's take a quick example here to think about the couple situations here. Identify the variables and the causal relationships between them. People from the suburbs oppose permits to use Chicago beaches. Which one's the X? Which one's the Y? How about poor people are more likely to use public transit? Which one's the X? Which one's the Y? Pause the video for a moment and think. All right, so in the first example, people from the suburbs oppose permits to use Chicago beaches. People from the suburbs is a reference to where they live. It's a place of residence. Those are the ones that are influencing where you live, has an influence on your opinion. Opposing permits is an opinion. So the X's and Y's in this case are the place of residence on the opinion of beach permits. The next example, poor people are more likely to use public transit, has income is a reference to the poorness of people. So you could be poor or not poor, or maybe it's a gradation of wealth, and it's influencing some form of transportation behavior. Public transit is one option, but there could also be options such as walking, taking a bicycle, taking a personal vehicle, or carpooling. So all of these are different types of transportation behaviors that could vary based on your type of income. This is a little clip found out on the internet here from the Wall Street Journal, where you have a couple penguins hanging out on an iceberg, and the caption says, "Do you think all these film crews brought on global warming, or did the global warming bring on all these film crews?" This is just a little fun bit, but I want you to kind of think about it a little bit in terms of these causal relationships. Which one is X, which one is Y, and which one is causing the other, or are they causing each other? So since we're talking about relationships, we have to really come back to this idea that sometimes you see things in statistics and it says that they're going to be related. There's some statistical relationship here. But statistical relationships, which we may cause correlations or associations, does not mean that they actually exist in the real world, which is what we're calling the causation. Correlation does not mean causation. Let's go back and reference again that graph from before, where we had the number of people who drowned by falling into a pool in the films that Nicolas Cage appears in. Statistically, it says, yes, there's a relationship. They track each other. As one goes up, so does the other. As one goes down, so does the other. However, we don't find this to be true in real life. If Nicolas Cage starts appearing in more movies, he and the number of films he's having is not the attribution that's causing the number of people that are drowning in pools. Which brings us to the idea of a confounding variable. Confounding variables are things that are data we don't know, observation points we don't have, that if we did, could attribute an explanation to the relationships we see statistically. Now, there really is no connection between Nicolas Cage and drowning victims in pools, but we could find certain examples out there, and we'll talk about these later when we get to the section on correlations and associations, where confounding variables, also called third variable problems, lurking variable problems, omitted variable biases, these are when having that extra piece of knowledge really unpacks the problem for us. So getting to the data analysis workflow, we kind of have this, well, it's a flow chart of the process that we're going to go through here. So we start with identifying the question. What is it that we want to know? And figuring out the population that that question applies to. Or maybe we figured out the population first and then we develop the question. These things can kind of happen together. And then we move on to developing hypotheses. So we have this question and we know a group we're trying to talk about, but we have this idea. So we come up with this idea in a formal way called a hypothesis statement, or hypothesis statements if we have many ideas, and we lay out what we're expecting to find. Then we develop a sampling procedure, and we're going to be talking about sampling in the next video series. And the sampling procedures are going to talk about how we go ahead and collect this data and make sure that the sample we collect is able to speak back to the population through what we call representativeness. The fourth process is where we actually go out, collect, and process the data. And when we do so, we may find some pitfalls and holes that we fall into. And so we're going to have to understand some of these challenges and document them, because you always want to be transparent in your data analysis workflow. Once you have the data, we then move on to using it to make conclusions. We use our statistical tools to talk about how big is it and what difference did it make and what is it that we saw. So then we move into evaluating those conclusions, where then we say, the things that we saw in the conclusions, are they random chance? Was it just dumb luck? And what kind of margins of error do we have on the conclusions that we had? Once we have a sense of all of these things, we can then go back to the hypothesis statements and see, did the conclusions support the hypotheses? Did they not support them? And we can talk about them. We can share them with our peers. And then the steps when we move into the programmatic part differ a little bit. The programmatic part is going to kind of fit inside our previous stages of collecting data, processing data, building the conclusions and whatnot. So those steps about 4 through 7 is where the programmatic portions come in. And this is where inside here, we source the data. So we're going through that collection process and we're building out code books and we're putting things together. It moves into a data file where we store it in something like a table or a CSV or R data, or we're getting the data from somewhere else as a source and we're putting it into the data files we can work with. Then we move on to programmatic commands. This is where you're working in the code and you're writing out scripts. And those scripts will produce output that we then use to do our interpretations. And before we go ahead and put it into the presented portion, we usually put it into a post-processing. So we develop into charts and graphics and things like that. So it's made more simple and easier to understand, especially for those that don't work in the realm of statistics and data analysis. And once we have those, we clean them up. You always want to make your products look good, because it's like they say, you dress to impress. And so when your things look good, it's easier to understand. People will look more at the messages you're trying to deliver there and less at the little flaws that you have all over your table because it's messy or cluttered or just doesn't look well. And you output it into something they can use, like a Word document or an HTML or however it is you do your delivery. So that kind of brings us towards the end of relationships and data analysis, but I want to start to key into the two different fields that we're going to be taking this analysis into. There's descriptive and inferential. The descriptives are just the summary characteristics, the visualizations, things that talk about the data that we have there. And oftentimes, potentially, descriptive reduces the data for quick meaning. Reduces, it means we have a whole vector of data or a whole data set, and we're packing that information down into just a couple key numbers or key data points that we're using as a reference. Now, descriptive data, we don't really have uncertainty and we don't use inference with it because it's typically on population data, not on a sample. We can do descriptive statistics on samples, but if we're doing it in that case, we're not using the descriptive statistics as the point of inference. I'm not saying the mean of this vector of data here refers back to the population. That's where I need the inferential statistics for. And types of descriptives include things like measures of central tendency, dispersion, and skew, which we'll be coming back to in our data refresher later. And so the inferential portion, that's the other half of the coin. And this is where we're using certain tools that we're going to build throughout this term to help us draw conclusions from the sample to generalize to the population. And with this, I'll see you in the next video.